What if I told you that the key to understanding how all software works really comes down to just understanding a simple phrase? Well, today, that's exactly what we're going to do. We're going to talk about something called expressions, and I think you'll see pretty quickly how they're the first step to really speaking a computer's language. All right, so let's start with a little puzzle. I'm about to show you 3 lines of code that look pretty different from each other. As they pop up, just take a second and think, what's the one thing that connects them all? Okay, first up, we've got 5 plus 2. Super simple, right? It's just math. We all know a computer can look at this and figure out the answer in a split second. Next, we have this, hello world. So this isn't really math, but it's another kind of task a computer knows how to do. It's joining 2 pieces of text together. And last one, major equals to 4. Now this one's different again. It's not really calculating a number, it's more like asking a question, isn't it? So we have a math problem, we have text, and we have a question. What on earth do these have in common?
Well, the big reveal is they're all expressions. And the easiest way to think about an expression is to just see it as a simple, complete phrase that a computer can not only understand, but can also respond to with a single, final answer.
And that's really the core idea right there. An expression is just any bit of code that a computer can look at and boil down to a single value. So 5 plus 2 becomes just 7, the 2 words become one complete phrase, it always ends up as one final thing.
And what's kind of cool is that expressions can be ridiculously simple. I mean, the most basic ones are literally just single values. A number, like 1.7, that's an expression. A piece of text, even a whole sentence, yep, that's an expression too. Even just the word true or a variable like sum, they all count because the computer can look at each one and resolve it to the single value it represents.
Okay, so if the simplest expressions are like single words, let's think of them as nouns. How do we actually build more interesting phrases? I mean, just like in English, we need some verbs to connect everything, right? And that's where operators come in. If our values are the nouns, operators are absolutely the verbs. They're the action words. They tell the computer what to do with all those values, whether to add them up, compare them, or stick them together. And as you can see, these operators can wear different hats. You've got your arithmetic operators for all the math stuff, but then you have string operators, where that exact same plus sign suddenly means, hey, join this text together. And then you have these super important comparison operators, which are all about asking questions that have a true or false answer. And that's exactly what you're seeing in a real piece of code right here. Expressions like these are basically just questions we're asking the computer. And the computer looks at them, figures them out, and gives us back a simple true or false. And believe it or not, that simple answer is the foundation for how every program makes decisions. Okay, now this is where programming languages get really, really clever. Sometimes the computer will see an expression that's mixing different kinds of data, like a number and a word, and it'll actually try to make sense of it for you. It kind of improvises. So check this out. We're trying to add the word August to the number 1977. In the real world, that makes 0 sense, right? But in a lot of programming languages, this actually works. It's because of something called type coercion, which is just a fancy way of saying the computer sees what you're probably trying to do, and it helps you out by converting one thing to another to make it work. So what happened there? Well, the programming language saw that plus sign, but it also saw the text August. So it thinks, you're probably not trying to do math here. You're probably trying to join text. So it just quietly turns the number 1977 into the text 1977 and then joins them together. It's a handy feature that's meant to make things a little easier. Okay, so we've talked about these little phrases. They're simple. They always result in a single value. But how do we get from these tiny little pieces to the massive, complex apps and websites that we use every single day? What's the connection? Well, it all comes back to those true or false questions. Every single time a program has to make a choice, should it show this pop-up? Is this password correct? Should this button be blue or green? It all starts with evaluating an expression. That tiny true or false result is what steers the ship. It directs the entire flow of the program. These little phrases are literally the bedrock of all digital logic. In this quote right here, it just nails why this stuff is so important. This isn't just some abstract theory, because sooner or later, your code is going to break. Everyone's does. And when it does, understanding how the computer thinks about each little phrase is your roadmap. It's what lets you trace the logic, spot the mistake, and actually fix the problem. So try not to think of this as some complicated technical thing you have to memorize. It's much more like learning the basic grammar of a new language. Once you really get a feel for how to build these simple phrases, you're well on your way to having a real conversation with the computer. And from there, you can start building whatever you can imagine. Thanks so much for watching.